Hello, class. You just had your second test, and the test scores are looking very good. Okay, so we are starting with Chapter 10. And Chapter 10, the beginning here, 10.1, 10.2 deals with systems of equations. And then we move into something called matrices. And then, and I believe we end with partial fractions. Okay, so 10.1 will probably be review for a lot of you. And then when we look at 10.2, even though it's still systems of equations, 10.2 will probably look a little bit different just because of the process. Okay, so 10.1, systems of linear equations in two variables. Okay, so what we're going to be doing here is we're going to be looking at several methods. So first we're going to take a look at graphing. And then we're going to take a look at the substitution method. And elimination method. Okay, and we're going to take a look at the solutions. So it's possible that you have one solution. It's possible that you have no solutions. And it's possible to have infinitely many. Okay. All right. So visually what that looks like is, okay, so if we're dealing with two variables, we're talking about lines here. But you could have systems of equations that are not linear. Maybe you have a parabola and a line, or maybe you have two parabolas, or maybe you have a circle and a line, or two circles, okay? But in this section, we're going to be dealing with linear ones, okay? So, so what that looks like graphically is, remember the line, when you graph a line of an equation, what you're really doing is you're graphing all the solutions, all the xy solutions to that equation. So all the xy points that fall on this line satisfy the equation of this line, okay? So every xy is a solution, okay? And so what happens here is with a system, you're dealing with more than one equation. And what you're doing is you're looking for an XY solution that is a solution to both of these equations, okay? So if the points on a line represent the solutions to each of the equations, then right here, this point falls on both lines. Therefore, this point would be the solution to the system. Okay, and in this case, we see that we have one solution. Okay, and we call this case a consistent case. Okay. Another possibility is you have one of your lines here, and then it turns out you have your other one over here parallel to it, in which case they don't share a common solution. So here, this is the case where they have no solution. Okay, and this is a case where we call it inconsistent. Okay, and we'll come back to this because here we're looking at what it looks like if you have no solution graphically. And when we start looking at these other methods, substitution and elimination method, for solving, then the question is, okay, well, when I'm using algebraic methods, how can I tell if I have no solution or infinitely many solutions. Okay, so the infinitely many case looks like this, where you have that line, and then the other line falls right on top of it. And so we have infinitely many. Okay. And in this case, we call this dependent. Okay. And again, so I'll come back to these two here, the no solution case and the infinitely many solution case. I'll come back to those, and we'll take a look at how can you tell if you have one or the other when you're not graphing it, but solving it algebraically. Okay, so leave some space below them. Okay. All right, so let's start off with the graphing method. Okay, so let's take a look at this one. Suppose that I have to solve by graphing. And suppose that I have this system. Suppose I have 2x minus y equals 5, and I have x plus 4y equals 7. Okay, so I'm going to go ahead and graph these two lines, and I'm going to see where they intersect. Okay, so hopefully you're pretty proficient with graphing lines. All right, so there's my x-axis, my y-axis. All right, so hopefully you can do these in your head. If not, here, let me just do the first one. Okay, so that first equation, I'm just going to go ahead and make a table. If you guys prefer to rewrite it so that the y is by itself, so it's solved for y, so that it's in slope-intercept form, y equals mx plus b, and then graph it that way, that's perfectly fine as well. All right, so if you're going to make a table, like normally I would just do this in my head, but I don't want to put down points, and then students are wondering, well, how did I get those points? So this is how I get it, but I do it in my head. Okay, so when x is 0, I see y is negative 5. So 0, 1, 2, 3, 4, 5. And when y is 0, x is 2.5. Okay, so here are my 2 points. And here is my line. Okay, and now I'm going to do the second one. I'm going to use the same method since they're both in standard form. And again, I would normally not do these charts by hand. I would just do them in my head. So when x is 0, y is 7 over 4, which is the same thing as 1 3/4. All right, so 0, 1 3/4. Okay. When y is 0, x is 7. I think I might be short here. There we go. 1, 2, 3, 4, 5, 6, 7. Okay, so we have that point and this point, and let me draw my line. Okay, so I have both of my lines here. So the question is, all right, well, where do they have a common solution? So the common solution that they have is right here where they intersect, and that looks about 3, 1, maybe. Okay, which is why we prefer to have those algebraic methods, the substitution method and elimination method, because if you're graphing quickly like this and you're not using graph paper, you're doing everything by hand, is that really 3, 1 or is that 3.2, 1? So, but normally, if you're on a test and you get somewhere close to 3 and 1, that would be fine. if you're doing it on Cengage WebAssign, they have the graphing feature there, so it'll be precise. You wouldn't be doing it by drawing freehand like this. Okay. All right. Let me do one more. All right, let's go ahead and here. Why don't you try this one as well, and then we'll come back, hit the pause button, and come back and see if it matches with mine. Okay, so solve by graphing. Okay, and suppose that you have this 3x plus 2y equals 14. And x minus 2y equals 2. Okay. All right. So if you want to give this a try and then come back, go ahead and hit the pause button. Okay, I am going to make a table for that first one. Again, normally I just do this in my head. When x is 0, y is 7. When y is 0, x is 14 over 3, which is 4 and 2/3. Okay, so 0, 7, 1, 2, 3, 4, 5, 6, 7. And 4 and 2/3, 1, 2, 3, 4, 2/3. Okay, and drawing our line. Okay, that's the first one. And then the second one, when x is 0, y is -1. When y is 0, x is 2. Okay, so 0, -1, 2, 0. Okay, so again, they seem to be intersecting over here. This seems to be the common solution, and that looks like it's maybe 3, 2. Maybe it's 3.5, 2. Okay. Again, if your graph is sloppy, then you'll be close. Okay, if you do everything correctly. Okay, if you got like 4, 1, that's okay. I believe the actual answer is 4, 1, but when I graph it sloppily like this, it doesn't look like it. Okay. But this one up here, this one was graphed a little bit better. The answer really is 3, 1. Okay. So the actual answer 4, 1. Okay. It would be really bad if you were like nowhere near 4, 1. 3, 2 is clearly close to the point 4, 1. But if you said, oh, well, the answer is some point that's over here in a whole other quadrant, then yeah, you did something wrong. Okay. All right. So let's take a look at algebraic methods, because not all of us can graph so perfectly. Okay, and we need a better way to get the precise answers. Okay, so let's take a look at the substitution method. Okay, so we're going to be looking at two methods here, the substitution method and elimination method. So substitution method, I like to use this one if one of your equations is solved for a variable. So if it says x equals or y equals, okay? Or if it could easily be written that way, okay? But it doesn't have to be, it just makes it easier. When it's not, then I just use the other method, elimination method. Okay, so this is a good choice if one equation is solved for one of the variables, and it doesn't matter which one. Okay? Or can easily be rewritten in such a way. Okay, so like these guys up here, let's go back to, so these here, so when they're written like that, I wouldn't use substitution method, I would use elimination method. But if you were going to use substitution method, it would be very easy if you rewrote this one so it said x equals negative 4y plus 7, right? And then same thing here, because they're written in standard form. I wouldn't use substitution method here. You could. You'd have to rewrite one of these, probably this one, so that it said x equals 2y plus 2. Okay. But to me, again, when they're written like that in standard form, I would just use elimination method. Okay. All right. So let's take a look. Solve by substitution. All right, suppose that you have this system, y equals 1 minus 2x, okay? So already that tells me I would probably use substitution method because it's solved for one of the variables. It's solved for y, okay? 3x plus 4y equals 14, okay? So even though this one isn't, it doesn't matter. So long as one of them is, it makes substitution method easy. So I don't have to rewrite anything. I can just go right off the bat, take this equation, right? So y equals 1 minus 2x, right? So I'm going to take that value of y. Okay, so here, let me get this. So I'm going to take all of this. Y equals all of that. So wherever I see a y, I'm going to replace it with this. Okay, so over here, I see a y, so I'm going to replace that with 1 minus 2x. Okay, so 3x plus 4, and right here, I'm going to substitute 1 minus 2x. Okay, and what happens is now you end up with an equation with just one variable, and we all know how to solve this equation here. So now I can just work this all out. 3x, distribute this 4. 4 times 1 is 4. 4 times negative 2 is negative 8. And I get this. Okay, combine like terms. Positive 3x and negative 8x is negative 5x. Okay, solve for x. Okay, and x equals negative 2. Okay, but we're not done because remember, we're solving this system of linear equations, right? We're solving this system, so we're trying to figure out where these two equations share a common solution. So we only solve for the x component. We need to solve for a point. So we need to find the y component. Okay, so far we only know this part, negative 2. Okay, the way we find the y component is we take that -2 and we plug it into any of the equations, okay, that we started with there. Okay, so I need y, so I'm going to go ahead and, again, you can choose this one or you can choose this one. Okay, it doesn't matter which one you substitute that -2 into. Okay, so I'm going to choose that first equation. So I'm going to solve for y. And I'm going to use the first one. Okay, so I don't know what y is, so I'm going to leave it as y equals 1 minus 2 times x, but I do know what x is. X is -2. Okay. All right, so y equals 1 plus 4, so y equals 5. Okay, so my final answer is -2, 5. That's the point of intersection. Okay, so my two lines cross here at -2, 5. Okay, let's take a look. So again, in this example, I had one of the equations already solved for one of the variables. It was solved for y. Okay, so let's take a look at an example where we don't have that. Okay, so solve by substitution. Okay, and suppose that we have these two equations. Suppose that I have 2x minus y equals 5. And suppose that I have x plus 4y equals 7. Okay, so here I'm not as fortunate, and I have to take one of these equations and rewrite it so that it's solved for one of the variables. Okay, so the easiest variable to get by itself would be the x that's in this one, because all I would have to do is subtract 4y, right, on both sides. Okay, whereas if I look at this one up here, okay, I can get the y by itself, but then I would have to subtract 2x, but then I also have to divide by -1. Okay, so that takes 2 steps. Doing the bottom one takes 1 step. Okay, either way, whichever one you decide to do, you'll still get the same answer at the end. Okay, so over here, I'm going to rewrite this so the x is by itself. So it's going to be -4y plus 7. So all I did was subtract 4y on both sides to get the x by itself. Okay, so now I can use substitution. Okay, so x is equal to all of this. So wherever I see an x, I'm going to replace it in the other equation. Okay, so right here, I see the x, so I'm going to replace that x with -4y plus 7. Okay, so 2, replacing the x with -4y plus 7, minus y equals 5. Okay, and there we go. We have our one equation with just the one variable. Okay, so let's distribute that 2. Okay, combine like terms. Subtract 14 on both sides. Okay, and we get that y equals to 1. Okay, y equals 1. All right, so again, we need to find a point. So far, we only know the y value, and we know the y value is 1. Okay, I need to find the x value, so I need to go up here, and I can actually use any of these any of these equations here, even the ones that were rewritten. I can use any of those two, or I can even use that one. Okay. All right, so I'm going to use the one with the red circles since it's already have the x by itself. All right, so x equals -4 times y, and we know that y is 1 because we just solved for it, plus 7. Okay, so working this out, x equals -4 plus 7, so x equals to 3. Okay, so that would be our answer right here, 3, 1. Okay. All right. Let's have you try this one. Okay, so go ahead and try this. Solve by substitution. And then you can come back and check your answer with mine. Solve by substitution. And suppose these are my equations. 2x plus 5y equals 15. 4x plus y equals 21. Okay, so go ahead and try that. You'll have to rewrite one of them. Hopefully you can kind of look at it and you can see, oh, it would be easiest to rewrite. I'll let you go ahead and do it. Okay, so hit the pause button and come back when you're done. Okay, so I am going to rewrite this one because it would be out of the 4 variables here, the 2 x's and 2 y's, the y in this bottom equation would be the easiest one to get by itself because all I have to do is subtract 4x. So y equals -4x plus 21. Okay, so that's what I'm going to substitute. Okay, so I'm going to substitute this -4x plus 21 where I see the y. Okay, so I see the y up here. So that's what I'm going to replace. Okay, so all right, so 2x plus 5 times, replacing that y with -4x plus 21 equals 15. Okay, working this out, distributing this 5, I get -20x plus 105 equals 15. Okay, and then here we get -18x plus 105 equals 15. Subtract 1, oops, hold on a second. Erase, there we go. Subtract 105. So -18x equals, come on, okay, -90. Okay, divide both sides by -18. And we get +5. Okay, so we found the x value. Let me bring down the system. Okay, so we found the x value. We need to find the y value. Okay, so I think I will use this version of the second equation. Okay, so y equals -4 times x, and I see here that x is 5 plus 21. So y equals -20 plus 21. So y equals 1. Okay, so the answer is 5, 1. Okay, all right. Okay, let's take a look at this next example. That way you can see what I mean by, oh, okay, well, there's, so far we've been doing equations that actually intersect, and so there's one solution, right? We haven't looked at how you can tell if the lines are parallel and you end up with no common solution, or if they are one line on top of the other, and so you have infinitely many. So let's take a look at this one. Solve by substitution. Okay, and suppose that I have this system. Y equals negative x plus 1, and 2x plus 2y equals 2. All right, so this one is ready for substitution. I don't have to rewrite anything because that first equation is solved for y. So I'm just going to go ahead and I'm going to, y is equal to this. So where I see the y, I'm going to replace y with that. Okay, so here's the y. So I will replace this with negative x plus 1. Okay, so 2x plus 2 times, I'm replacing that y with negative x plus 1 equals 2. Distribute. So 2 times negative 1 is negative 2x. 2 times 1 is 2. Okay, combine like terms, and these guys end up canceling out, and I get 2 equals 2. Okay, so my variables disappeared. Okay, so when your variables disappear, then one of two things happens. Okay, you either get the same number on both sides, 2 equals 2. Okay, or you get two different numbers. So maybe you get something like 0 equals 2. Okay, so if you get the same number, okay, a true statement, so your variables disappear. They ended up canceling out. Okay, so your variables cancel out, and you're left with same number. Both sides. Okay, in other words, a true statement. Okay, 2 equals 2, that's true. Okay, so when that happens, then this is the case where you have infinitely many solutions. So once your variables cancel out, you can stop because you either have infinitely many solutions, like this case, and that's all you do is write it. Okay. And that's the case where you end up with the same number, 2 equals 2. If you end up with two different numbers, like 0 equals 2 or 5 equals 7, okay, those are all not true. They're false, right? So when you end up with something false like that, that's when you have no solution. That's when you have the parallel lines, okay? Okay, so this one here, this system here, we have infinitely many solutions. So that's the case where you have a line on top of the other. Okay. All right, so let's take a look at elimination method. So that's substitution method. Let's take a look at elimination method. Okay. So this is a good choice. If no coefficients are 1 or -1. Okay, so let me give you an example. Okay, so we already know about substitution methods. So if you take a look at this one, solve by elimination. Okay, suppose that you have this system, 3x plus 2y equals 14. And x minus 2y equals 2. Okay. So here you could use elimination method, or you could actually use substitution method. Either method would be fine here. To me, since they're both already written in standard form, I'm just going to keep them this way. I don't want to rewrite anything if I have another method like elimination that I can use right off the bat. Okay. So here, to use elimination method, what you're doing with elimination method, also known as addition method, is you're going to be eliminating one of the variables, x or y. You're going to be eliminating them by adding the two equations together. Okay, so what happens here is they automatically will eliminate when I add them, right? When I add these two equations together, right? I combined them. So that's what I'm doing. I'm combining these two equations. 3x and 1x is 4x. 2y minus 2y, eliminated. Okay. So I don't have to put anything there. And 14 and 2 is 16. And then here, I solve this equation. Divide both sides by 4, and I get x equals 4. Okay. I still have to find the y value. Okay, so far we know this much. So I will use, I think I like this bottom one a little bit more than that top one. Smaller numbers, right? Okay. All right, so 4 minus 2y equals 2. So now I just need to solve for y. Remember, I plugged in the 4 for x because I solved for x. All right, subtract 4. So I get negative 2y equals negative 2. Okay, divide both sides by negative 2, and I get that y equals 1. Okay, so that would be my final answer right here, 4, 1. Okay, so this system here, because you do have this 1x right over here, this system, it would be fine to use substitution method. It would be fine to use elimination method. Again, both methods work. It's just that sometimes, depending on the numbers you have, the equations that you have, one might be a little bit easier to work with than the other. But you could use elimination. You could use substitution for all of these. Okay, so let's take a look at this one. Solve by elimination. Okay, suppose that I have this 8x minus 2y equals 5. Okay, and negative 12x plus 3y equals 7. Okay, so if I try to, so clearly here, I don't have like a 1x or a 1y anywhere. so that if I do choose to use substitution here, well, if I try to get any of the x's or y's by themselves, then I introduce fractions, right? Like over here, if I try to solve for x, oh, I'm going to end up having to divide by 8, right, at some point. Okay, introducing fractions. Okay, so here, this is what I mean when up above, I said, oh, elimination method, that's a good choice if no coefficients are 1 or -1. Okay, so that's why here in this first example, that x that's circled, you have a 1x, so you could easily use substitution method here. And this one here, while you could use substitution method here, just you better be good with fractions, okay? All right, so here I would definitely use elimination over substitution if I had a choice, okay? All right, so we can see here if I add these two equations together, 8 and -12, that's not going to cancel, right? -2y plus 3y, that's not going to cancel. So I don't end up eliminating any of my variables if I add these two right off the bat, right? The only way I can eliminate them is if they have the same number but opposite signs, like a 5x and a -5x, or a 7x and a -7x, or an 8y and a -8y, or an 11y and a -11y. Okay, I don't have that here. So what you have to do is you have to make them the same number opposite sign. Okay, so what you can do here is choose what you want to eliminate, x's or y's. I usually go for the smaller, okay? So here I would choose to eliminate the y's. Again, it doesn't matter, okay? So if I want to eliminate the y's, they need to have the same number but opposite signs, right? So right now it's a -2 and a +3. Okay, so I need to make them a common number. So I have to think, what can I multiply the 2 by, and what can I multiply the 3 by so that I end up with the same number opposite signs? Okay, so here, so try to think of like, remember when we did like common denominators, right? It's kind of like that. You're trying to find a common multiple, okay? Something that's a multiple of 2 and a multiple of 3. Okay, so that would be 6. Okay, so you're going to try to turn the coefficients of y into a 6 and a -6. Okay, so let's take a look. So if I want to do that up here, well, I already have the negative. So what I'm going to do here is I'm going to multiply both sides of the equation by 3. And if I do that, multiply both sides of the equation, I'll get a -6y. And then over here, if I multiply both sides of this equation by 2, then that will give me a +6y. And then they will be able to eliminate, okay? All right, so let's take a look at what we get when we multiply everything in that first equation by 3. So I get 24x minus 6y equals 15. Okay, and then that bottom equation, when we multiply everything by 2, I get -24x plus 6y equals 14. Okay, all right, so this is what I get. Here, let me fix that. It's a little messy. Okay, so this is what I get, and now I can go ahead and eliminate. And oh, well, look what happens here. This eliminates, and this eliminates. All of my variables got eliminated, right? That means I got 0 on this side. And on the other side, I end up with 15 plus 14. That's 29. So this is that other case. all of your variables cancel out, and you're left with not a true statement, a false statement. So here is the case where you have no solution. So that means that these two lines are parallel to each other. Okay? All right, so let's go ahead and go back to the very beginning of the notes where I said I'll come back to this. Way up here. Okay, so here. So we can tell when we have no solution and infinitely many from the graphs. But if we're not using the graphing method, we're using one of the algebraic methods, then we need some other way to tell when we have no solution and infinitely many. Okay, so the no solution case would be if you have this example, like what we just had, 0 equals 29. Okay, infinitely many case, many solutions, all of your variables cancel out, and you're left with this, 29 equals 29. That's true. Okay. All right. So hopefully you know the difference. Okay. All right. Let's go ahead and, okay, so there's elimination method. Here's elimination method. I'm going to go ahead and do another one with fractions because even though it's all the same, I think some students get tripped up with fractions. All right, so let's take a look at this. Solve by elimination. Okay, suppose that your system is this: 1/2 x plus 1/3 y equals 2, and 1/5 x minus 2/3 y equals 8. Okay, so here, so remember, you could always get rid of your fractions. You can always clear your fractions. Okay, so I'm going to take a look at that first equation. I'm going to go ahead and ignore the bottom one. Okay, I'm looking just at that top equation. Okay, so I'm not even going to try to figure out what I need to multiply by to eliminate. I'm not going to do that. I'm going to just clear my fractions. Okay, so let's put a little note here. Let me see. Clear fractions. Okay. And the way you do that is you multiply the entire equation, multiply equations by the LCD. Okay. All right, so that top one, I have two fractions there, 1/2 and 1/3. So my LCD between 2 and 3 is 6. So I'm going to multiply this equation by 6 to cancel out both of those fractions. Okay. The bottom equation, I have two fractions as well. Okay, so the bottom equation will have a different LCD because I have 1/5 and 2/3, negative 2/3. And so I have 5 and 3 for my denominators. So my LCD is going to be 15. So I'm going to need to multiply this by 15 to get rid of my fractions there. Okay. All right, so let's go ahead and do that. Right now, all we're doing is clearing our fractions. And then once we do that, then everything becomes the same process as the ones up here. Then you can decide what you're going to multiply by to eliminate. Right now, we're just deciding what to multiply by to clear our fractions, not to do the elimination method. Okay. All right, so distributing that 6 to the 1/2, 1/2 of 6 is 3. 1/3 of 6 is 2. 2 times 6 is 12. Okay. All right. So there we have that first equation rewritten so that we have no fractions. Okay, same thing with the second one. 15 divided by that 5 over there is going to be 3x. That's convenient. Okay. 3 goes into 15 5 times the multiplied by -2. So that's going to give me negative 10y. Okay. And 8 times 15, that will give me that 90 again. We've seen that before. Okay. Oh, wait, hold on a second. That is not. That's 120. Okay. So now, decide what you're going to eliminate. It should be kind of obvious if you're going to eliminate x's or y's. So looking at these two equations here, it's easier to eliminate the x's because we already have matching numbers. We just need to have one of these be opposite sign. So I'm going to go ahead and multiply this by -1. Okay, there we go, -1. Okay, because now what I'm doing here is trying to figure out what do I need to multiply these so that I can use the elimination method. All right, so that top equation is 3x plus 2y equals 12. And that bottom one is -3x plus 10y equals -120. Okay. And now I can use the elimination method. Those cancel out. And I get 12y equals -108. Okay. And then if I divide both sides by 12 here, that's terrible looking too. Okay. All right, I get y equals -9. Y equals -9. Okay, and then now we need to go back and solve for x because so far I only have this part of our answer, something -9. All right, so let's go up here. All right, so we've got all these equations, right? I would pick the one that has the smallest numbers. Um, you could pick any of the ones with the fractions. That's fine. I notice a lot of students are uncomfortable with fractions, so I'm going to pick this equation, 3x plus 2y equals 12. 3x plus 2 times -9 equals 12. Okay, and now I can solve for x. Scroll. 3x minus 18 equals 12. Add 18. Okay, and 3x, those will cancel. So 3x equals 30. So x equals 10. Okay, so my answer here is going to be 10, -9. Okay, so that is that would be elimination method. Okay, now here's the thing. Where is my infinitely many solutions? Okay, that's the no solution case. Okay, so right here, see how it's infinitely many solutions? So the way we write that now, so back in the past and maybe some of your other math classes, this would have been good enough. Oh, infinitely many solutions. Okay, so what we're going to be doing here now is we're going to introduce t. Okay, so we're going to say, okay, so we have infinitely many solutions. X is some number. Y is some number, okay, and we have infinitely many of those, okay? So the way we're going to write our answers now is we're going to say, okay, I'm going to let x equal t, okay? And then you can take that t value. So you pretend like that's an actual number that you solve for, right, for x. So now we have that, and we need to find the y value, okay? So normally, if that's an actual number, we would take that actual number, plug it into one of these equations, and solve for y, right? So I'm going to take that t, okay, and I will use this one, this top one, okay? So x equals t. So coming back down below where it says let x equals t, then y equals negative t plus 1. So now I substitute that t value in for x, and that's what I get. So over here, for my point, I have t for the x, and I'm going to have negative t plus 1 for the y value. Okay? So all you do here is solve for y. Okay? And you do that by plugging in t for x and then solving for y. And so you're not going to get an actual number. You're going to get some expression in terms of t. Okay? So that's how I would expect you to write it on the test. And maybe that's the way WebAssign expects you to write it. If anything, they would probably change the letter. Sometimes they use the letter A. Okay, so you'll have to check. Okay. All right. So that's it for 10.1. Okay, if you have any questions, make sure you email me or you message me. Again, the quickest way to get a response out of me is to reply to one of my remind announcements that you've been getting on your phone. Okay.